Hey, yo, welcome back to my bench. Well, actually, this isn't my bench. This is on my floor. This won't fit on my bench. This was brought to me by a customer. A Peavy amp. It's a bass combo Mark III series. It's a bass amp and bass speaker all in one. I'll show you the 15-inch driver. It's massive. It's got like 1 inch, made from 1 inch pressed MDF. Thing's massive and heavy, but this came to me because it's got a fault, and from what I understand, the fault is they'd be playing and then the volume would just drop off to nothing and it would cut in and out. So it was brought to me to have a look at, service if possible, and we're going to do the best we can for this gentleman. It's marketed as a bass amp, but I think you could use it for guitars as well. It's got 2 inputs. It's got a pre-gain, and then you got your equalization here, these 5 pots. These 3 are parametric. You got your frequency. You can shift your frequency bandwidth. Like this one here, bandwidth, it either puts it a sharp bandwidth or a wide bandwidth. And this one shifts the frequency at which that notch happens, or that peak. And this is your mode. I guess it gives it a minus 17 or plus 17 dB cut or boost. And you can boost or cut the highs by plus minus 15 dBm. And then you got your post gain, which is probably your main volume control for your amplifier. Compression switch with limit light, and output for another amplifier. It's got your preamp out. So it's a fairly modern unit. I'm guessing it's mid-90s. The thing about Peavy is I have a little trouble finding their, they have all their service information online and they make it freely available to everybody. But the problem I'm finding is they have a problem with numbering and labeling their equipment. And try and find this piece of gear in their lists of service information. It's almost impossible. I wish they would have come up with a better numbering scheme or naming scheme that would have prevented that. But let's have a look at the back. Back of the enclosure, it has a grounded power input. And see, this is another thing. It says Series 260C, but if you look up Series 260C, you see nothing, and that's what's really frustrating. It's got a power switch with on, which means this is hum reduction, so you can either select whichever one reduces the hum the most or has the least amount of hum. 5 amp fuse. 2 outputs for other speakers, 4 ohms, 130 watts. So it's got a 130 watt amplifier in it, mono amplifier. And we're going to tie into this and see if we can do something. So like I said, the complaint is you'd be using the amplifier and it would cut out or go quiet, which isn't good when you're doing live music. So we're going to have a good look at this. I have a good feeling I know what's wrong with it already, but I don't like speculating, but I'm just going to say it right now. It's probably, since it's a bass guitar unit and it's got vibration obviously, I'm guessing it'd be cracked solder joints would be the main cause of what's going on here. So we're going to open it up, have a good look at it. It could be something else like a transistor doing weird stuff when it's thermally activated, but we'll try our best to get this thing going. I'm going to have to feed it signals. I don't usually use 1/4 inch inputs or 1/4 inch jacks for my on my bench, so I might have to rig something up to feed it a signal. Obviously I don't have a guitar here, so we'll do our best for this gentleman and see what we can do for it. Alright, so next step I guess would be take the amplifier out of the cabinet, and it all comes out from the back, I'm guessing, and we'll go that way. Yeah, there's screws all the way around, and it looks like some of the screws are missing, so somebody's probably been in here trying to figure out what's going on with it. But yeah, we'll get this amplifier up on the bench and we'll have a good look at it. Okay, so I got the cabinet gutted and moved on to my bench, and it comes in two parts. There's the front panel, which is just a big aluminum plate that holds, you know, potentiometers, a couple active circuits, and input, and you know, a few connectors. So I'm going to put this one aside for now, and we're going to work on the back panel. This is the back panel. As you can see, it has the amplifier and power supply. Big ass transformer on here. It's got the switch with the reversing polarity for the input mains. It's got a couple of outputs for the speaker that's wired in parallel. Remove that. And there is a thermal cutout switch that kills power to the unit if it overheats. What do we got here? 5,000 microfarad at 55 volts. Okay. And then it's just, you know, heat sinking. Back panel's your heat sink. Big fat rectifier diodes here. So remove these transformer connections. I took pictures of all this. I believe I did. Just so they don't get mixed up. And I think, yeah, they're polarized so that you can't really mess them up. And we'll just remove the chassis from the PCB from the chassis. Okay, so I am finding a few problems on the soldering of this board. It looks like some of the soldering was, some of these leads were trimmed after the soldering was done. And I can see a few of them here where they're quite a poor joint actually. There is one broken connection here. Where was it again? Right here. This one. But this is a resistor and capacitor in series, and it's across the speaker output. That's the what do they call it? Zobel network? That's loose. But that's not going to cause our problem of fading out. One thing I am looking at right here that's suspicious is these two 15-volt regulators. 7915 and the 7815 plus minus 15 volts. These are notorious for failing, and there's really no heat sinking on them, so it's a possibility. What I might do is I might just change these two voltage regulators, because it supplies all these chips with power. And I saw a few spots here where I'm going to have to figure out or touch up the soldering. There was one here. I'll have to go over it again. But I went over it with a micro magnifying glass, and yeah, there's definitely one there. Other than that, everything looks good. Some of the soldering is a little bit questionable. I haven't done any ESR on the caps yet. I don't expect them to be bad, but we'll check a few while we're here. I can get this in frame and you can see it. So what do we have here? Yeah, I didn't expect to see any bad caps. They're all looking good. So we might have if we're getting intermittent sound or sound that's cutting out, we could have either a problem with this power supply, these two regulators could be intermittent or failing. these sockets for these ICs, they can be questionable too, especially everything there's nothing that's gold plated here. Transistors, could be one bad transistor. It is a mono amplifier, so one transistor in the link could cause it all to fall apart, right? But I'm going to fix up those few solder joints, and then I'm going to turn my attention to the other board too, because that might be a fault on there. So something else I'm seeing here is these connectors are not the greatest. Some of them are very tight, some of them are, like this one came off loose. So this is the preamp out, and from what I can see, this switches. It's not just a simple output, it switches off the internal amplifier from what it looks like. It's got 4 wires, 2 feeding out and 2 feeding back. So that might be a source of the problem right there. And the rest of these are just LEDs. This is a switch. See, some of these are very tight. I can't even get them off. Where's my screwdriver? Yeah, they're very tight. And then the next one beside it is loose. So I'm going to have to go through and make sure that they're all good. No flaky connections anywhere. That's not what we want. Oh man, see, that one wouldn't come off at all. Okay, so I got that off. I'll remove these. Pretty sure that there's nuts on the end of these pots. So I'll pull all these pots off, and we'll pull this board out and have a good look at it too. So here's the tone board, I guess you call it, and it's all the solder joints look good on this one. No problems here. Kind of concerned about these cheap sockets they use for the ICs. That's my biggest concern on this one. And then these Molex connectors. But I haven't seen any problems here yet. I'm just going to go through and check the ESR. And I expect everything to be good. And they are. Everything's good. I'll give these pots a cleaning, and we'll reseat these integrated circuits. These are Texas Instruments TL074Cs. They're just op amps. And you can see the silver plating on the pins turns black with oxidation. So I'll just reseat these. Should actually clean that. Makes contact on the inside of the pin, so you get a Q-tip and just clean it with some deoxit. Maybe restore that contact, make sure it's 100%. Okay, so we're going to go through these pots and we're going to test them out and clean them. And I'm just going to pull one out at a time here. I don't want to pull them all out because I don't want to mix them up. What I've done is before I've gone through and removed the solder from 2 of the pins and left the 3rd one. And the 3rd one I can just get with the soldering iron. So we have a ohm meter here. I put a fresh battery in it this morning. So let's test these pots, see how stable they look. Let's do the low side first. Just connect up an ohm meter. and go through its range. This is a 10K pot. $10K. Okay, let's go to a different range here. Let's go to 1K range. Let's try this again. So start off at 0 and slowly open it up. And I don't see the meter twitching around or jumping or... We are at 9K, I think. So that pot looks clean, but we're going to clean it anyway. Let's get some... Going to use this contact cleaner, zero residue. This will flush out any of the bad stuff. You can see the liquid coming out, it's kind of brown. Give it 2 or 3 flushes with this stuff. See the brown stuff coming out. That's probably mostly lubricant, but there is dirt in there. You can see dirt. Okay. Now that that's cleaned, we're going to add some Deoxit F100. It's going to give it a little shot on the contact. Make sure it carries through to both sides. And work it. Yeah, let's try this again. It's looking good. Okay, I'll put that back in and we'll go on to the next pot. Let's do one of these 50K pots. Okay, what do we got here? Looks fairly clean. If I wipe through it, go through its range, it's holding out. Let's try the other side. Pretty good. I don't think these pots need changing. I think they would just be cleaned and they'd be good enough. So let's clean this one as well, and then we'll work through the rest and be done with this. I don't know if you can see this, but it's washing. This stuff's really aggressive. It washes out all the lubricants and whatever else was in there before. You can see the grease coming out. It's like a grease. but it's also flushing out a lot of dirt and crap. But if you're gonna use a contact cleaner, you gotta put something in its place, because this will strip all of the lubricants out, and you need to have something in there. And that's where this F100 comes in. Does a good job of for the faders, the sliders. You don't want to flush all that lubricant out, because your pot would be running dry and it would just disintegrate in a matter of no time, because it's got no lubrication, and it would be not good. I think who makes this? CAIG Laboratories. They make another product that is it's almost like a paste or a grease. Like if you're going to disassemble a pot, you can use that stuff and it would provide better protection even, because it's more like a grease or a lubricant. Okay, so what I'm going to do here is I'm going to install the board back in the chassis here upside down, and I'm going to put the nuts back on the pots. And you're probably wondering why I'm doing this. Is because what I want to do is I want to make sure all the pots are aligned properly and the board is seated before I start soldering. That's important, because if you just solder the pots to the board, when it comes time to installing them on the front panel, you might have to bend one way or one another way. And what that does, all it does is it puts stress on the solder joint and the leads for the pot. And if you do it this way, there's no stress on the leads, because everything's aligned before you solder it. See, I need to tighten these up so they're all in place. So I'll get on with that. And I need a tool to tighten these nuts up. It would be nice if I had a nice socket. What is that? It's like a 9/16 socket or 5/8. I don't know if this is metric or not. It's American, so it might not be metric. See, now it's all lined up. Pots are lined up. And I can seat the board properly onto these pots, and I can go from behind and start soldering. Alright, so what I've done here is I removed the input the input connector for the preamp. This connector has flow through, and what I mean by flow through is the signal from the preamp is provided to one of these pins, and it makes contact in here like a switch. So if there's nothing plugged into this, the signal should flow through it from the red wire to the white wire, or vice versa. I don't know which it is. But when you plug in a 1/4-inch phono jack, it breaks the connection between the two, and it provides the output to the phono jack, and it doesn't allow the signal to flow through to the amplifier, the internal amplifier. So it essentially cuts it off. But what you can do is you can take, if you I suspect this the switch contacts in here are dirty, so what I can do is I can just take this out. These are just pressed in, and there's a little locking latch here. Sorry, there's a little locking latch that catches on the plastic, which prevents it from pulling out. But if you bend that down, you can pull out the leaf, let's call it. Give it a little bit of a bend up again so it latches next time you shove it in. Sorry. And right here, this is the contact for the phono plug. And it looks like it's all black and dirty. And then back, where's the other spot? Back here somewhere, it's supposed to make contact with this one. So let's pull this white one out too. Let's bend this down a little bit. I don't want to do too much here. And see if this pulls out. Nope, needs more. There, it's going to come out now. They're in there tight. Now you can just replace these. You got to find the right kind. This one had some rubber or something. What is that? I don't know. But anyways, here's your contact here, and it's all oxidized and brown and black with oxidation. So let's clean it. Let's try something. Let's try this stuff. This vintage stuff from Radio Shack. It's coming off. But I think the abrasive action of the Q-tip is probably more. I don't really recommend taking sandpaper to this because what you're dealing with is a thin layer of silver plated. You don't want to remove any of the metal. But that's where I'm going to take it, and actually what I'm going to do is I'm going to stretch this spring here a little bit to give it a little bit more contact tension. Just a little touch. So we got them cleaned up pretty good with the alcohol, or the cleaner. I'm just going to put some deoxit on the contact points, just to help with the contact, and then we're going to put these back together again. So I lifted the little tab up a little bit. I can do it with a screwdriver. Let's see, where's my screwdriver? You can do it with a little screwdriver and just give it a little lift, just to, so that when you slide it back in, it's going to latch again. It won't come out on its own. There we go. This one's in tight. And this one as well. All right, so let's check it. Let's test it with an ohm meter, make sure we got continuity. So we got white and red. You know what would work better is if I used an ESR meter on this, a low ohms meter. We zero this. Okay, so what we got here for resistance on these contacts? 0.02. It's pretty good. There's another set of contacts in here I can see. Probably can't see them on the camera, but it's between this pin and this pin, but they already have this one bridged. Another thing you could do is, if you have persistent problems, is you could bridge these two, and they would always be making contact, and you would never be able to cut out the internal amplifier. Or you could wire a switch in, maybe, I don't know. But this is, I think we got the problem with this. I'm suspecting this was the problem with the amplifier, the reason why the sound was cutting out. You got a high resistance contact on there, and that'll do it. So I'm going to put this back in and call her done. And we'll do some testing on the amplifier, obviously, of course, but this is good. This comes from Switchcraft, and I don't think there's a part number on here. But you could probably find this in DigiKey. Go look for 1/4-inch phone connectors, and it should be there. But you got to remember, this is not a metal jacket one. This is insulated. This is plastic, so it's insulated from the chassis. And you want this to be insulated, because if this was a metal sleeve on here and it made contact with the chassis, you might get a ground loop, and might be causing hum. This is all isolated. All these wires are isolated from the chassis, so even the ground. So the ground's the black wire. Alright, so I've gone through and I've resoldered probably a dozen connections on the back here. There was only one broken solder joint, and the remainder were kind of flaky looking, and so I just went through and redid those. Couldn't find much going on with the soldering on this board. ESR caps are good. One thing I want to do, I was thinking of replacing these 2 voltage regulators. They are working. But what I'm going to do instead, I'm just going to put little heat sinks on them. And I got 2 little heat sinks here. We're going to put those on and give those 2 regulators a little bit better chance of cooling. I don't even know if they do get hot. I don't know how much current. This board probably consumes, these little ICs here probably consume a couple, maybe 100 milliamps at the most. But I'm going to put a little bit of heat sinking on there just to make sure that these are happy and they're not cutting out from being over temp, because they are internally regulated for short circuits and over temp and stuff like that. So I'm going to do that next, and then after that it's assembly and put it back in and test it out. Okay, so I got the heat sinks installed on these 2 regulators and a little bit of heat sink component in there. Pretty much everything's done to this that I want to do. I reseated these 2 chips. I'm not pleased with the quality of the sockets they use. I guess they're okay, but if this were my amplifier, I'd probably take these sockets out and solder these chips directly to the board. And that just eliminates one step that could go bad. But then, you know me, I'm such a fussy person. But everything looks good. Got it all back together. And like I said, I resoldered a bunch of random spots here because they didn't look that great, but they do now. So everything's going to go back into the chassis. Just gotta pull out the power supply section and we'll get this mounted in. Okay, we're going to do a little initial test here. I got the amplifier back in the cabinet. I'm going to turn it on. Nope. That amplifier's got a shorted output. I guess I should have tested it before I took it all apart. But looks like we're going to be doing some more repairs. That's alright. We'll get her. Okay, a couple things. I finally found a schematic for this amplifier. This goes by the number 260C, and this is the older version of the schematic because there's two versions, one printed 78, one printed 90 or 81, and this is the actually the correct layout and circuit diagram. So on the outputs they have tandem transistors. There's 4 NPN transistors, and they're all identical. And we had that huge voltage swing on the output, and I suspected some of these transistors were shorted, so I removed these 2 and I checked them on my diode checker, and it seems like they're okay. Like they came back pretty good with the voltage drop across the junctions. But then I got looking and I started comparing these 2 together, and this one actually has a lower voltage drop across the emitter, base emitter junction. So I'm beginning to suspect this transistor is maybe leaky or damaged. So what I did is I took it out, and I'm going to try this transistor alone. So what I'm going to do now is power this up, and I'm going to check for voltage on the speaker outputs, and hopefully it doesn't blow up when I turn it on. Okay, here we go. This is ground, and yes it did. We blew up a chip. Okay, let's pull this chip out. This is run from the plus minus 15 volt supply. Yeah, let's pull this chip out. Pull this one out as well. This one might be damaged too. All right, let's try this again. It's negative and positive. And we still got 42 volts, 41 volts on the output. All right, so I got the power amplifier working. A couple takeaways for myself mainly is if you're going to work on one of these power amplifiers, don't remove the op amps from their sockets because they're required to be in circuit to allow for proper biasing. And that was what I was seeing there when I turned the power on. I was getting full DC on the outputs, on the speaker output, and that was absolutely my fault. Another takeaway is don't install the op amp backwards in the socket because it releases the smoke when you turn the power on. Okay, so I'm all wired in for a power test. I have everything connected, I hope. I got signal source. I'm going to feed in a 1000 hertz tone. I'm going to watch it on the scope, and let's do this. Okay, turning it on and turning up the volume. Adjust my scope settings. Okay, so I'm feeding in 1 volt right now, peak to peak. I'm getting 11.6 volts RMS out. Let's keep going up. This is supposed to be 130 watts into 4 ohms, so I do have a 4 ohm load connected. Let's keep going. They're already into clipping. Oh, hang on, let me turn this. Okay, we're at clipping. 22.5 volts RMS output on 4 ohms. Okay, I want to turn this down because I don't have I don't have a lot of heat sinking here. There's actually no heat sinking. It's just a aluminum extrusion that's bolted to an aluminum plate. So there's no fins, there's really no thermal mass here. So I don't want to run this long and overheat it, but I am gonna let it cook for a while, let it get hot. Sounds like everything's working good. .52 volts. Okay. Sounds like it's performing pretty good. So what I'm going to do is I'm going to shut this down. Turn that off. I just don't want to overheat the oh, it's not even warm yet. Well, it is warm, but it's not hot. But that's good enough for my test. That's all I wanted to see. So we're going to put this back in the cabinet and finish it off, get it back to the customer. Okay, just doing a final test here, just to make sure it's good before it goes back to the customer. One thing I forgot to mention, the two filter capacitors, these are rated at 5,000 microfarad. One of them measured out at about 4,500 and the other one measured at 2,000 microfarad. So I replaced both of these with 6800s, and just to get rid of that. I didn't mention that in the main body of the video, but I got a Heathkit. What is this? A Heathkit number IG5282. It's a little battery powered transistorized audio generator that I have used for many years. I've since retired, but I brought it out of retirement just for this video, so I'm going to plug it in. Let's turn this on. Actually, let's do this first. Turn it on. Plug this in. And we are getting a signal. I turn it up. It's minimum gain right now, so it's working. Let's turn this back down. Turn on the generator. And what are we at here? I gotta turn this on too. Okay, there we go. Distortion on this. Okay, let's 40 hertz. It's all working as expected. Let's try it with a different frequency. Scratchy knobs, I know. seems to be. This is not a high. What do we got it set at? We got it set at 6,000. Mike, we don't need 6,000. Okay, so I think it's ready to go. I think we're done. Seems all the functions are working. No scratchy pots. You know, it's hard to test with just pure tones. You got to connect a guitar to it and listen to it. But I think it's ready to go, and I hope the customer's happy with this one. All right, thanks for watching.